Hey friends, Mrs. Scandrel again. Guess what? You know what teachers really love? They love fidget spinners. Yeah, they really do. You know what else they really love? They love it when kids get pencils and they do like this. And they take them apart. They play with the lead. Or they just spin. Yeah, no. We really hate that. It drives us crazy. But it's a good learning opportunity. So here we go. I'm going to teach you 2 words right now. Compose and decompose. Decompose means to take apart. So I can take this fidget spinner that I actually really like, and I can decompose it. I can pop this, take my paper clip, the other thing that teachers don't like because kids pull them apart. I can pop off the caps like that, and I can pop off, the other cap on the other side because I want to know how it works. So if you look in the middle of that fidget spinner, you have these little metal balls, and they're inside of these 2 circles, these 2 metal circles, and they sit inside a groove, and those ball bearings is what they're called, allow that fidget spinner to spin. That's how that works. I decompose my fidget spinner to figure out how it works. I also do that with pencils. You know why these things are outlawed, right? Because kids, we do this thing all the time. Yeah. But I can also decompose a pencil. A mechanical pencil. These are outlawed in school. Teachers hate them because kids, me, I do this stuff. We twist it. I'm going to decompose a pencil. I'm taking it apart. My mechanical pencil, not my regular pencil. Taking the eraser off, and I'm pulling out the inside. And I'm pulling that out. I'm looking at this. I'm like, ooh, this is fun. And I can see that if I go like this, it has kind of feel like a spring. I'm not going to take that apart. But we take things apart. We decompose them to figure out how they work. When we compose them, it means that we put them back together. We put it back together and we make it whole again. So decompose means to take apart, and compose means to put back together. So teachers prefer that you not decompose your pencil during math class, or any class for that matter, but especially math because you might need it. In any case, fidget spinners, I like them. Most teachers don't, so just, keep it on the down low, like slide it in your desk or something. So anyway, today we're going to talk about fractions. You have to be able to compose and decompose a fraction in more than one way, recording each composition and decomposition as an addition or subtraction equation. Really? All that means, how can you take a fraction apart, and how can you stick it back together? Decompose it, take it apart. Compose it, put it back together. That's all that means. You have to be able to do those things, though, using an area model and a number line. Area model, number line. Y'all, number lines all around us. You build anything? I like to build stuff. Measuring tape. It's a number line. All those little dashes. Fractions. It matters if you measure right. You should measure something 3 or 4 times. Make the cut once. Okay? Make sure your measurement's accurate. If you're building a table, your table will wobble. Fractions matter. It's real life. You need to know them. So here we go. I'm going to show you a couple of things. First of all, let's say you are given the fraction, and we'll start with a simple fraction. Very simple. Typical fraction. We will start with the fraction 3/4. And you were asked to decompose that fraction and show by adding. Decompose the fraction to show how it can be written as an addition equation. So I could take 3/4, and I know that 3/4, let's see, there's my whole. 1, 2, 3. So that means that I have, out of my whole, I have 3 of those that are colored in. That's what that means, 3 out of 4. How could I write this? Well, I could take my 1/4 and say 1/4 plus 1/4 plus 1/4 equals 3/4. This is my area model. This shows me what 3/4 looks like. And I could break it down and say 1/4 plus 1/4 plus 1/4 equals 3/4, because it does. I took 3/4 and I decomposed it by showing an addition problem. And when I add 1/4, 1/4, and 1/4, I'm composing that number, I'm composing 3/4 again. So there's another way to do this though. I could take my fourth, and instead of saying 1/4 plus 1/4 plus 1/4 equals 3/4, I could say, oh look, could I put those 2/4 together plus 1/4 and get 3/4? Why yes I can. So I could say 2/4 plus 1/4 equals 3/4. So I've just shown how I can add fractions, or how I can decompose a fraction and show it as an addition problem, which is what you're going to need to know how to do. So the next thing you're going to be asked to do is figure out how you can add two fractions. So I'm going to show you how to do that. If I have a fraction 2/4, I'm willing to bet you can draw an area model to show 2/4. So this is what my whole is. And I've taken my whole and I've broken it down into 4 equal pieces. And I think by now you can figure out that all you have to do is color in 2 of those 4 pieces. Well, guess what? Check. We took care of this one. Yay. We took care of the 2/4. Now we have to add 3/4. Well, I can go back over to my whole, and I have 2 available fourths left. So I can say 1/4, 2/4, but I need to add 3/4. I've only added 2 more fourths. So guess what you do? You go out and you draw another whole that's just like the first one. And we're using an area model to model this, because that's just what you're going to have to do. You're going to have to model using the area model how you do this. So I have 1/4, 2/4. Here is my 3/4. Guess what? Now all I have to do is count the pieces. 1, 2, 3, 4, 5. I have 5 fourths. I have 5 units that are a fourth of the whole. Now, some of you might be saying, well, Mrs. Kendra, why isn't it 5/8? Can't I just add 4 plus 4 and that gives me 8? No, you can't do that. You know why I can't do that? Because your whole is broken into fourths. It's not broken into eighths. So don't let that confuse you. That is something really common that everybody messes up on when they first start adding fractions. If your denominators are the same, your denominators are the numbers that are downstairs. They're the ones that tell you how many pieces your whole is broken into. You keep your denominator and you just add your numerators together. And if your numerators happen to be greater than one whole, you just go out, you get another whole, break it into fourths, and keep going, or whatever your denominator is. Okay, so now we have to have a conversation about these number lines, because that's the other way you have to model a fraction, or model an addition equation using a number line. So number lines get kids really, really confused, and I get it, because we're not used to seeing stuff like this, and you have to first read the number line. So if I have my number line here, and there are some markers already indicated on my number line. I have the 0 point, that's where it's 0. I have 1, so from here to here is 1. From here to here is 2. From here to here is 3. Those arrows on the end indicate that that number line keeps going in both directions forever and ever and ever, never stops. But we just have a section of it because my house isn't that big and that long, and, well, I don't have that much time. So here we go. I have to examine how my number line is broken up. So I have to look between 0 and 1 and ask myself, how many chunks or units is that broken into? Well, I don't count my lines, I count the units, what's in between. So 1, 2, 3, 4. Ha, aha. So that must mean that my number line is already broken into fourths. So from 0, if I think about 1, I can name 1. Because this is broken into fourths, I can name one whole 4/4. Because this is 1/4, 2/4, 3/4. Well, one whole is also known as 4/4. Well, guess what? I keep going. 4/4, 5/4, 6/4, 7/4. I'm at 2. What do I name 2? Haha, 8/4, 8/4, 9/4, 10/4. fourths, 11 fourths. What do I need 3? 12 fourths, equivalent fractions. That's why we spend all the time with equivalent fractions. Oh, look at all those things making connections. Wow. So now I have a problem here. This is 5 fourths plus 3 fourths. Now, instead of using an area model to demonstrate how you add these fractions, we're going to use a number line. So if I look at my number line, and I like using colors because it helps my brain see things differently, because my brain works differently. I like colors. Colors help my brain file stuff. If you're like that, if you like things color coded, you're not weird. You're normal. Totally normal. It helps our brain. Okay. And if you're getting confused and struggling with stuff, try color coding. It really does help. So 5 fourths, I'm going to take my green marker and I'm going to count off 5 of my fourths. Well, I know 5 fourths is right here because I went ahead and I labeled my number line, but I have to show this. So that'd be 1, 2, 3, 4, 5 fourths. Let me get my orange marker because now I still want to add 3 fourths to that. 1, 2, 3. Where do I end up on my number line? From 0, if I had 5 fourths plus 3 fourths, guess what? I end up at 2, which is also known as 8 fourths. And so what I just did was I showed you how to use a number line to help you add a fraction. And so I like going here. This shows my 5 fourths. And this part here shows my 3 fourths. And when I add those together, I end up getting, oops, I messed up my number line. I end up getting 8 fourths, which is the same thing as taking your numerator, 5 plus 3, and you get 8. And it ends up being 8 fourths. So that's how we use a number line to add fractions. So friends, this is how you use number lines and area models to compose and decompose fractions. That's all you have to do. And if you get caught with a fidget spinner or taking a lead pencil apart, innocently look at your teacher and say, I'm so sorry. I was decomposing it so I could figure out how it worked. I was just really curious. Might work. I don't know. Might not work. It depends. Fidget away. Shh, quietly. You're decomposing things. You're learning.